All right, realized as class wrapped up that I completely forgot to start recording, so I'm just going to record the lesson real quick. We're going to be looking at our notes, and the notes are on Edsby, so you can find them there. If you haven't already printed them out, you can just jot some notes from this. So let me share the screen here for those notes. So first thing we're looking at is no solution systems. All right, make sure we got that on there. So no solution systems. And any system with no solutions means that the lines do not cross. All right, because lines that have a solution or systems that have a solution are two lines that cross at a single point. Right? If they don't cross, it means that they are parallel, and parallel lines have the same slopes but different y-intercepts. Okay, so if we look at these two equations in slope-intercept form, y equals mx plus b and y equals mx plus b, right? We have the same slopes but different intercepts. So these are going to be parallel lines. So if we just kind of look at the graphed versions of these, this is the negative 2x plus 1. So if I go to graph my y-intercept first, that's that point there, right? My slope is negative 2 over 1, which means I'm going to go down 2 and right 1, or I could go up 2 and left 1. Either way, gets me this line. All right, this one then, I go to my y-intercept at negative 1, okay? And then I'm going to use my slope to go down 2, right 1, or up 2, left 1. Right, as you can see, as these things change the exact same way every time, right, they're always going up and left or down and right, the exact number of times each one, they will never get closer together, right? They're always going to be this distance apart, and so they will never cross. They are parallel lines, okay? So if we don't see the graph, if we're just given the equations, the easiest way to tell that is this information, that they have the same slopes, but different y-intercepts. When that happens, when you have the same slopes, they're going to be either the same line or parallel lines, okay? So when lines have different slopes, okay, this is sort of a key piece of information to knowing that you have a one solution system. If they have different slopes, okay, so for example, if this had been negative 2x plus 1 and this had been negative 3x plus 1, for example, those would be lines that cross. No matter what the slopes are, if they are different, they will always cross. So they will always have one solution in a system, okay? So parallel lines, easy to recognize, same slope, different intercepts, okay? So second part of this is infinite solution systems. And infinite solution systems are actually the same equation, and they are sometimes in two different forms, okay? So I forgot the word sometimes, so I add that in. And if we look at this equation, right, graphing it, we would go to plus 2 at our intercept, and then up 3, right 1. We could keep doing that, or we could go down 3 and back 1, down 3, or down 3 and back 1 from there. So that would be the graph of that line. Now this line is not in slope-intercept form, so in order to tell what type of system we have here, whether it's a one solution, an infinite solution, or a no solution system, we need to get it into the same format. So we talked about this in the last unit of changing standard form into slope-intercept form. So the first thing I'm going to do is I'm going to move this x term to the other side. Okay, so by doing that, what I need to do is add 6x to get rid of this minus 6x. So I'd add 6x to both sides, giving me 2y equals 6x plus 4, right? I can't actually add these two, so I just get a two-term right side instead of a two-term left side now, okay? Then the second thing is I'm going to divide by that y coefficient to get y by itself. So I divided all of these by 2, right? And simplifying them, I just get 1y or y. I get 3x, and I get 2, okay? So that is my slope-intercept form. Notice it's the exact same as that one now, okay? If this had already been in the same form, I wouldn't need to have done any work. I could just go, these are the same lines. They're going to graph right on top of each other. And that's what I did here. I did it in red. for this one, and then I did it in pencil for this one. So you see they're right on top of each other. Okay, they don't ever not cross. They're constantly crossing. Okay, so if they don't cross at just one point, but they cross at every point, that means that there are infinite solutions. Okay, so that's what we would need to look at for any of these problems. So let's go take a look at the IXL section real quick. Get to it on IXL. Switch over my screen for you. All right, so what we're working on today is on 8th grade math, all right, and it's down here at AA5. You can also just get to it through the EDSB link if you'd like, and we'll click on that and do just a couple of sample problems from here once it loads. All right, so all of these are going to be the same type of problem. They'll give you two equations, usually in slope-intercept form, and then those three options. Okay, no solution, one solution, or infinite many solutions. As you do this, ask yourself one question first, and then if your answer to that is yes, ask yourself a second question. Okay, so first question, are the slopes the same? Okay, in this case, the answer is no. If the answer is no, this is automatically a one solution system. Okay, because with different slopes, lines will always cross. Okay, and they only cross at one point. So when I have different slopes, one solution problem. Okay, this one, as we look at it, ask that question again. Do they have the same slopes? In this case, my answer is yes, right? As I said, when your answer is yes, ask yourself a second question. Do they have the same intercept? If the answer to that is no, that means that they are parallel lines, right? Because parallel lines have the same slope, but different intercepts. Parallel lines will never cross, meaning that it's a no solution system. Okay, if your answer to the question of after you get this as a yes, if your answer to this of do they have the same intercepts is yes, that means they have the same line and they will have infinitely many solutions. Okay, so this is a yes, they have the same slope. No, they don't have the same intercepts. That's parallel lines, no solution. Okay, so this one, do they have the same slopes? -2, -3/4? No, they will cross. Okay, different slopes, one solution. Do they have the same slope? Yes. Second question, do they have the same intercept? This one is a yes. That means they're the exact, I mean, you can probably look at that and tell, right? Exact same equation, exact same line. It will graph right on top of each other and constantly be crossing, meaning they will have infinite solutions. Okay, so sorry that this didn't happen with all of the kids in class asking questions. I completely forgot to hit that record button, so hopefully this will help you out. And if you need any additional help, please come see me during my office hours either today or tomorrow or even Friday morning. All right, so check EDSB for those office hours Zoom codes, and I can help you out if you have any questions. All right, thanks, have a good day. Fist bump. Stop share.